Hi everyone. In this video, I will be talking about the six trigonometric ratios. So if you can still remember, during the start of the semester, I told you guys that Math 101 is a review of both algebra and trigonometry. So for the first half of the semester, we talked about the basics, the things that you needed to know or to review about algebra. So at this point in time, we'll be talking about discussing or reviewing some basic concepts that you need to know or you need to recall when we will be talking about trigonometry. Also, if you can still remember, I think you also had trigonometry during your junior high school years when you were in grade 9. So, most probably, you're already familiar with this topic. But nevertheless, let's try to, or let me try to discuss or to review to you some basic concepts regarding trigonometry, starting with the six trigonometric ratios. So, by definition, trigonometry is the study of triangles and their relationship among their sides and angles. And if we break down the word trigonometry, it actually comes from two Greek words. The first one is trigonon or trigonon, which means triangle. And the second word is metria, which means measure. So again, trigonometry is derived from two Greek words, trigonon or trigonon, which means triangle, and metria, which means measure. So therefore, trigonometry basically would be dealing with triangle measurement. Now, when talking about the six trigonometric ratios, we would be dealing with the right triangle. So if you can still recall, in geometry, we have different types of triangles. We have in terms of the angles, so we have an acute triangle, we have an obtuse triangle, and we have the right triangle. So we will be focusing with the right triangles mostly in trigonometry. So when we say right triangle, it is a triangle with a right angle. So a right angle in terms of measurement measures 90 degrees. So here in our illustration, we have triangle A, B, C. So if we will be naming the sides opposite a certain vertex, this is side A, this is side B, and this is side C. Also, let angle theta be an acute angle. So here. So these are actually important so that later on we'll be able to identify the six trigonometric ratios. But before that, let's talk about the different parts of the right triangle that will be in relation with the six trigonometric ratios. So this side right here, side C, this side is what we call as the hypotenuse. So take note, the hypotenuse is the side opposite of the right angle, and the hypotenuse is the longest side in a right triangle. Again, the hypotenuse, that is the side opposite of the right angle. So that is denoted by side C. The next one, with respect to angle theta, we have what we call as the opposite side. So basically, the opposite side is the side opposite the angle theta. And in our illustration, that is side A. Again, opposite side is the side opposite to our angle theta. And lastly, we have what we call as our adjacent side. When we say adjacent, it means beside. So in relation to our angle theta, the adjacent side is the side adjacent to the acute angle. So here in our illustration, the adjacent side is side B. So again, hypotenuse, that's side C. Opposite side in relation to angle theta, that's side A. Adjacent side, adjacent to angle theta, that is side B. Okay? Now, let's go ahead and identify the 6 trigonometric ratios. The very first one is what we call as our sine theta. Now, sine theta, the ratio is denoted by opposite over hypotenuse. Again, sine theta is denoted by opposite over hypotenuse. So, therefore, that is A over C. Okay? Next, we have cosine theta. Now, cosine theta, the ratio for that is adjacent over hypotenuse. So adjacent is side B, hypotenuse is side C. Next, we have tangent theta. Now, tangent theta is denoted by the ratio opposite over adjacent. And opposite over adjacent, in terms of sides, that is A over B. I think during your grade 9, your teacher might have told you there is actually a mnemonics for this in order for you to better recall or for you to remember easily the trigonometric ratios. So for the first 3 ratios, we have what we call as the we have what we call as the SOHCAHTOA. So SO stands for sine is equal to opposite over hypotenuse. Ka means cosine is equal to adjacent over hypotenuse. TOA represents tangent is equal to opposite over adjacent. So this is very helpful for you to better recall the first 3 trigonometric ratios. So again, that's SOHCAHTOA. Now let's proceed to the reciprocals of the first 3 trigonometric ratios, starting with cosecant theta. Now since it's the reciprocal, so we simply look for the reciprocal of this certain ratio. So if it's opposite over hypotenuse, so we will have hypotenuse over opposite. And in terms of side, that is C. So that's hypotenuse over opposite, which is also, in terms of sides, C over A. Next, by the way, cosecant theta, that's the reciprocal of sine theta. Now for the reciprocal of cosine theta, we have secant theta. Now since cosine theta is adjacent over hypotenuse, so since it's the reciprocal, secant theta is hypotenuse over adjacent. And in terms of sides, since it's the reciprocal, it's C over b. And lastly, for the reciprocal of tangent, we have what we call as cotangent theta. And since tangent theta is opposite over adjacent, the reciprocal for that is adjacent over opposite, or in terms of sides, that's b over a. So earlier, we had the mnemonics for the first three trigonometric ratios. Now for the reciprocals, of course, we have a mnemonic for that. So earlier, our mnemonic was SOHCAHTOA. So for the reciprocals, our mnemonics are ko, sha, cow. So ko, sha, cow. For cosecant, that's cosecant is equal to hypotenuse over opposite. Sha, that's secant, is equal to hypotenuse over adjacent. And cow, that is cotangent equals adjacent over opposite. So again, try to utilize those mnemonics for you to better recall the trigonometric ratio. So that's SOHCAHTOA and COSHA-COW. Let us go ahead and try an example. So find the 6 trigonometric ratios of angle theta. We are given this right triangle with sides that measures 3, 4, 5. So starting with sine theta, let us determine the ratio. So if you're still not very familiar with the sides, you can actually try to label. So again, the longest side, that's our hypotenuse, or let's just put hype. Opposite the angle theta, that's the opposite side, and adjacent to the angle theta, that's the adjacent side. And you can also write the mnemonics SOHCAHTOA and COSHA-COW. So starting with sine theta, we know that sine theta is equal to opposite over hypotenuse. So opposite, that's 4, hypotenuse is 5. Therefore, sine theta is 4 over 5. For cosine theta, so if we use the mnemonic, cosine theta is equal to adjacent over hypotenuse. And adjacent is 3, hypotenuse, as we know, is 5. For tangent theta, so tangent is equal to opposite over adjacent. So the opposite side is 4 and the adjacent side is 3. So therefore, tangent theta is equal to 4 over 3. So let's proceed to the reciprocals. So we have cosecant theta, that's the reciprocal of sine theta, secant theta, which is the reciprocal of cosine theta, and cotangent theta, which is the reciprocal of tangent theta. Now, since these are reciprocals, we can actually just refer to the first 3 trigonometric functions and look for the reciprocal. So since sine theta is 4 over 5, we can conclude that cosecant theta is 5 over 4. And if we try to use the mnemonic, just to check, cosecant theta is hypotenuse over opposite. So hypotenuse is 5, opposite side is 4. So that's 5 over 4. Secant theta, the reciprocal of cosine theta, is equal to 5 over 3. Now, checking, secant theta is equal to the ratio hypotenuse over adjacent. Hypotenuse is 5, adjacent side is 3. Lastly, cotangent theta. Again, that's the reciprocal of tangent theta. So that is equal to 3 over 4. And checking, cotangent theta is equal to adjacent over opposite. Adjacent side is 3, opposite side is 4. So, given this right triangle, these are the 6 trigonometric ratios. We now proceed to example number 2. So, if sine theta is equal to 3 over 8, find the other 5 trigonometric functions. So, sine theta is given, which is again 3 over 8. So we know that sine theta, based on our mnemonics, the ratio for that is sine is equal to opposite over hypotenuse. So the measurement of the opposite side with respect to our angle theta is 3, and the measurement of our hypotenuse is 8. So we only have 2 sides. How do you think can we find the other side? So I think during your junior high school years, you were introduced to the Pythagorean theorem. I'm sorry. That's Pythagorean theorem, which was introduced by Pythagoras. So the Pythagorean theorem, that is c squared equals a squared plus b squared. So we know that c squared is c is our hypotenuse. So that's 8 squared. Our a is 3 plus b squared. So in order for us to determine the measurement of the adjacent side, or this side, we need to use the Pythagorean theorem. So if we solve for that one, that's b squared equals 8 squared is 64, 3 squared is 9. So 64 plus 9, that's 55. Therefore, b is the square root of 55. Therefore, this side measures, or the measure of that side is the square root of 55. So, since we already know the measurement of the third side, we can now proceed in getting the other trigonometric ratios. So, we have cosine theta. So again, if you're still like having a hard time like determining the trigonometric ratios, you can always make use of the mnemonics. So cosine theta, that's adjacent over hypotenuse. So adjacent is square root of 55, hypotenuse is 8. Next we have tangent theta. So tangent theta is opposite over adjacent. Opposite is 3, adjacent is square root of 55. Now I think I've already discussed to you regarding radicals. So we will know that the denominator cannot have radicals. So we need to rationalize this one. So multiply square root of 55 to both your numerator and denominator. Therefore, that is 3 square root of 55 over 55. Now, proceeding to the reciprocals. So, cosecant theta is the reciprocal of sine theta. That is 8 over 3. Secant theta, the reciprocal of cosine theta. That's 8 over square root of 55. Again, we cannot have a radical in our denominator, so we need to rationalize. If we multiply both the numerator and the denominator by the square root of 55, we will have 8 square root of 55 over 55. Now lastly, for cotangent theta, which is the reciprocal of tangent theta, that is simply the square root of 55 over 3. Now it's okay if the numerator is a radical. It's fine as long as the denominator is not or doesn't have any radical. So therefore, these are the 6 trigonometric functions or ratios given this certain right triangle. If you have any questions, feel free to comment below on the comment section, or you can also try to send your questions in our group chat in order for me to answer your queries. Thank you so much, you guys. And also, I'm sorry, regarding your attendance, kindly comment your complete name and your block number. You take care. Bye-bye for now.